Welcome back to Aurora Tech Channel. I'm Aurora Lung from Danville, California. Today, I have an Ender-3 Pro that I recently purchased. And obviously, this isn't a new model, and it didn't come with any new exciting features. You may be wondering why I would buy another Ender-3 Pro. I have made a few videos about other printers, and I did compare them with the Ender-3. It actually performed quite well. I couldn't find any significant differences between the Ender-3 and other more expensive printers. My brother and I got our first Ender-3 about 3 years ago. At the time, we were complete beginners to 3D printing. We learned a lot from upgrading it and discovering and trying to solve its issues. Since then, many new budget 3D printers have flooded the market. Some of them have better features, but some of them are not as good as the Ender-3. I would say that the Ender-3 really set the standard for printers at around $200. So, after 3 years, I got another Ender-3 Pro to see how it has changed and how it performs without any upgrades. Another reason is that the Ender-3 Pro was on sale at the beginning of April, since Creality was celebrating their 7th anniversary. I actually got this for $184, which is just $5 more than the Ender-3. In my previous videos, I talked about how the Ender-3 Pro has 3 major upgrades compared to the Ender-3, including a wider 40x40 aluminum extrusion on the y-axis, a magnetic bed, and a mean well power supply. All of these upgrades are worth about $45, so we save some money by only having to pay an extra $5. Last year around October, Creality announced that all their new 3D printers would ship with a 32-bit board. I think it's an amazing deal. This is a really tiny box. The size is similar to the Ender-3. The parts aren't assembled like other printers you can buy these days, like the CR6SE, where you basically only need to mount the gantry with the base and install the screen and filament holder. I think the Ender-3 Pro will be the same as the Ender-3, which requires a little more time to assemble. This can be quite frustrating if you're a beginner, since there are a bunch of loose parts. This time, my brother and I assembled and disassembled this printer before we filmed this video. We wanted to find out which steps are easy for beginners to get confused about. Let's open up the box and see what's inside. We have the power supply, the base with the hot end, an LCD screen, and 4 aluminum extrusions. The x-axis motor, the limit switch, and the extruder are on the left of the gantry. The support plate is on the right side of the gantry. We also have the z-axis motor, the lead screw to control the z-axis, a filament holder, some screws, the zlimit switch, the belt and the tensioner for the x-axis, some couplers for the extruder, the power cable, and some tools. The main difference between the Ender-3 Pro and other easier to assemble printers like the CR6SE and the Sovol SV01 is that you have to put the gantry together by yourself instead of already having it pre-assembled. Besides that, it's pretty much the same as all other Cartesian printers. The most confusing part for a beginner is probably assembling the x-axis. I will cover this part in detail. Before we start, we need to check the voltage of the power supply. Make sure it's set to 115 if you're in the US. Then, take the base and check the wheels at the bottom. If you do this after everything's already assembled, it's harder to adjust the wheels. We don't want any wheels to spin alone. They have to move together. Turn the knob to move the wheels closer or further away from the extrusion to adjust the tightness. Once it seems okay, you can start assembling the printer. The manual from Creality is quite simple, but the pictures and instructions are easy to follow. We will follow the manual, but we'll also add some details that weren't in this manual that beginners may easily get confused about. Step 1. Connect two 20x40 extrusions to the base. In this step, we need the base, two 20x40 extrusions, and this bag of M5x45mm screws. These two extrusions are not identical, so please make sure they are in the correct position. One of them has two screw holes at the bottom. Put this one at the left side of the printer. The side with two screw holes goes to the base, and there's no front or back side for this extrusion. Since these two holes are for the Z-axis stepper motor, we will do this later in step 4. You can flip the base like this so it's easier to put in the screws. Make sure it forms a perfect 90-degree angle. The left side is done. Now, let's do the right side. This extrusion has two screw holes on one side, and the side with screw holes should face the inside. These two holes are for the power supply unit, which we will do in the next step. Use two screws to fix it in the base, like the one we just did. Do a final check to make sure they both form a perfect 90-degree angle with the base and that they are parallel to each other. After this step is complete, your frame should look like this. Step 2. Connect the power supply and the screen. This step is pretty straightforward. Grab the power supply, the screen, the M5x8mm screws, and the M4x20mm screws. The short screws are for the screen. Let's mount it at the right corner. Then, use the long screws to mount the power supply. The power cable connector and the power switch should be facing the outside. Step 3. Install the Z-axis limit switch. In this step, we just need the Z-limit switch. Loosen the T-nuts, but make sure not to unscrew them completely. Then, align it on the left side of the printer. Tighten the screws and make sure the T-nuts rotate and lock themselves in the slot of the extrusion like this. Step 4. Install the zstepper motor. The left 20x40 extrusion has two holes, which are for the zstepper motor. Grab two M4x18mm screws and just tighten the motor at the back of the left side. It should look like this. Step 5. Install the extruder on the x-axis. Grab the longer 20x20 extrusion and two M4x16mm screws. You need to put the extruder on the side where the screw holes are closer to each other. The side that has a big round hole should face up. Put the screws in. You need to slip it between the extruder and the aluminum extrusion, and then tighten them through the holes on the metal plate like this. Finally, grab a coupler from the tool bag and screw it into the extruder. If you did everything correctly, the x-axis will look like this. Step 6. Install the print head and the right side support plate on the x-axis. Take a look at the assembled printer. We have the print head on the x-axis, and we also need another plate at the right side to support the x-axis. For this step, we need the plate, the print head, and two M4x16mm screws. You can slide the print head to the center of the extrusion. The printhead with the fan should be at the front, and the extruder should be at the back. Next, put the support plate at the back and secure it with the screws. The x-axis should look like this. Steps 7 and 8. Install the belt and the belt tensioner. In this step, we need the belt tensioner and the belt. Lock one side of the belt onto the printhead where there is a slot at the bottom. Lock it in like this, and make sure the teeth of the belt are facing the extrusion. Then, go around the gears on the motor and go under the pulley wheels of the printhead to the other side. Now, put the tensioner on. Loosen the T-nuts on the tensioner the same way we did for the Z-limit switch. Let the belt go around the wheel. If you did everything correctly, the x-axis will look like this. Step 9. Attach the x-axis to the gantry and install the lead screw. In this step, we need to attach the x-axis to the gantry. You need to adjust these nuts to make it looser or tighter in order for it to fit. We don't want any wheels to spin alone. They have to move together. However, don't screw it too tightly, or the stepper motor may not be able to move the gantry up and down, or the rubber wheels will wear out faster than they're supposed to. Then, turn the lead screw all the way down to the coupler and secure it. Make sure the lead screw reaches the bottom. If you did everything correctly, the printer will look like this. Step 10. Install the top of the gantry. In this step, we need the last 20 by 20 extrusion, M5 by 25 mm screws, and 2 end caps. This step is pretty easy. Just put the extrusion at the top, but make sure the side with larger holes faces up. Push the end caps at both sides of the extrusion. Now the printer looks like this. Step 11. The filament holder. The filament holder is divided into two parts, the mount and the roll. Grab 2 M5 by 8 mm screws and T-nuts. Just put the mount on top, but put it at the left side of the printer as the extruder is on the left. Then, screw the roll onto the mount and you're done. Step 12. Connect the cables. Now, we will connect the power supply cable and the screen. The cable should go to the EXP3 connector, which is the one closest to the print bed. Then, connect the white Bowden tube from the print head to the extruder. Grab the blue spacer from the tool bag to secure the coupler so the tube won't slip out. Also, add one to the hot end heat sink. Finally, connect the cables for the motors and the limit switch. The cable with the E tag is for the extruder. There are two cables with the X tag. The 6-pin is for the X motor. The 3-pin is for the X limit switch. There are another two cables with the Y tag. The connectors are located at the back of the printer. The 3-pin is for the Y limit switch, and the 6-pin is for the Y motor. Finally, the 6-pin Z cable is for the Z motor behind the 20 by 40 extrusion, and the 3-pin Z cable is for the Z limit switch at the left side of the printer. Make a final check for the print head. Make sure it can move freely with a little bit of dragging. the wheels should spin together. When you move any of them, the print head should also move. You can adjust the nut under the print head to make it looser or tighter. Check the belt tension. Right now the belt is too loose. Loosen the belt tensioner. Use a screwdriver to pull the tensioner away to add more tension to the belt. Then secure the screws on the tensioner. Now the belt tension is better. Turn the printer on. Press the knob to show the menu. Go to Prepare and select Auto Home. Now, the printer will move all the X, Y, and Z axes to trigger the limit switches so they are all in the 0 position. We still need to level the bed. We want to move the bed close enough to the print head so the filament can stick on the bed when we print. Some people prefer to use a G-code file to move the print head around, but I will disable the stepper motor and do this manually, and move the bed to the bottom left corner. You can put a paper between the nozzle and the bed, since most of the time we're printing at a 0.2 millimeter layer height, which is just about the thickness of a paper. Turn the knob to move the bed up and down. Make it close enough to the nozzle so that it scratches the paper slightly, but the paper should still be able to move. Do this to all 4 corners and the center of the bed. Normally, the center of the bed is a bit low, so you can't feel the slight drag, but it doesn't really matter too much. You may need to do this several times so that it's perfect. Now, let's heat up the nozzle and feed in some filament. After the nozzle reaches 200 degrees, push the lever and feed in some filament. Just push it all the way in until you see some filament coming out from the nozzle. Let's do a test print. Since I usually don't install any of the software that comes with a printer, I will install Cura. Go to Ultimaker to download the latest version. After you have it installed, add a non-network printer and select Creality 3D Ender-3 Pro. For our first print, I will do something simple. Let's just print a test file to make sure our bed is leveled at all corners. We will print some circles to make sure the belt tension is right. If the belt tension is not right, you can't print a round circle, as it requires both the X and Y axes to move correctly. The printer has now started printing. The nozzle is still a little far from the bed. In this case, select Tune from the menu, adjust baby steps, and move it to -0.1. The nozzle still isn't close enough, so I'll move it a bit closer. Okay, it sticks pretty well now. Let it finish the print. This 1-layer test print looks fine. Now we can try some other prints. For example, I'll print a phone stand. I use default profile for all printers and let them print right out of the box. So far, it seems that Ender3 Pro is doing pretty well. I printed the same model with the Ender5 Pro. You can compare which one looks better. Next, we will try a more difficult print, the Eiffel Tower. A model like this requires a huge amount of retraction, so I'm a little worried if the Ender3 Pro can handle it. My first print failed, but it's not because of the retraction. The magnetic bed can't stick well enough to the bottom of the tower, since it has such a small contact surface. Then, I tried to use a PEI spring steel sheet instead. The print failed again, because in the middle of the print the nozzle clogged. I heard the extruder stepper motor clicking, which means the filament cannot be pushed all the way through. I paused the print and pulled the Bowden tube out to check. The reason is that the Bowden tube at the hot end side was cut badly. The factory didn't cut the tube straight enough and left a gap between the nozzle and the tube. When you print something that requires a lot of retraction, it becomes an even bigger problem. I had to cut the Bowden tube properly and restart everything. It printed for a while until it clogged again. This time, the filament clogged at the end of the Bowden tube instead of the gap between the tube and the nozzle. I think the reason is that when the print is close to finishing, the tower becomes more narrow, and it requires the extruder to push in a bit of filament and immediately retract it back before it goes to another position. A print that requires that much retraction is a bit tough for the stock Bowden tube setup. We can compare the unfinished tower to the prints by the Ender-3 with a direct extruder. The print from the Ender3 Pro is actually quite nice. If I change the stock Bowden setup to a direct extruder, which was able to print this model without any issues, the Ender3 Pro should be able to finish this print. Finally, I will try to print another model, the Arc de Triomphe. This model doesn't require too much retraction, so let's see how well this Ender3 Pro prints it. Generally, a larger flat surface on each layer is easier to print, because it only requires the extruder to push in the filament and do some retraction once in a while. I left it to print overnight, but as you can see, it ran out of filament. When I saw it the next morning, it was missing the top. But it still looks pretty nice. That's why I think a filament runout sensor is a must. It only costs a few dollars, but it will save your time and filament to avoid situations like this. Then, I used another roll of filament to reprint this model. The Overture Rock PLA strings more than Creality's white PLA, but this time, it finished the print and stringing is quite easy to clean up. So the model looks pretty good. In conclusion, I would say that this printer is great. It's quite beginner friendly and it has good quality control for most parts, except for a very minor issue. In my case, it was that the Bowden tube inside the hot end wasn't cut straight. Another issue is that the position of the heated bed cable support is too high. When the bed moves all the way to the front, it touches the nozzle. If the nozzle was heated, it would melt the plastic. But besides that, I am very happy with everything else. It's definitely worth the price, and it's a great choice for your first budget printer. Since this printer is so popular, many people have added a lot of different upgrades. I will make more videos about upgrading this printer. I'm going to spend around $100 to add upgrades that can really improve the print quality. That's it for this video. If you like this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you'll see something new. See you next week.